Alright, Chapter 5 of the complete printed circuit board design using Orcad capture and layout. Chapter 5 Introduction design for the manufacturer. Introduction for the PCB, the assembly with the soldering profit. For the PCB, the manufacturer of the bare board has to be able to fabricate with the same fabrication allowances. The board has to be able to be assembled with a given with the difference component of the technology discussed in the previous chapter. There are many types of the design, fabrication, and printed circuit boards. When the design is complete, submitted with the board, however, they must be able to perform the manufacturer step of the design calls for. Whether the PCB is manufactured or not really begins with the include with the parts of the creation schematic entry into the capture pad stick with the footprint design, player replacement with the tracing routing, and finally the post-processing and layout. But it does not end there. Once the board has been fabricated, it is so little use without the functional part. The parts need not to be able to be attached to the board without them or the board being damaged. Parts attachment encompasses with the position of the part that depends on the proper placement and with the orientation made with the reliable soldered joints between the component lead of the board mounting pads, which depends on a good pad stack with a footprint design with the chapter provide with the information necessary for the pad stack with the footprint design component placement with the design manufactured PCBs. Assembly profit. The printed circuit board may be manually assembled or assembled with the automated machinery. Assembly profit depends on the class of the component technology class A through Z as described earlier. Number of the boards assembled at one time. Some of the companies will fabricate with the assembly boards under one roof, while some companies are specialized within PCB fabrication only and other PCB assembly only with the method of assembly play with the role and how you will lay out your PCB because of the clearance for the orientation issue for the soldering profit, the brief summary with the assembly profit, the given here with the along with the competent placement, orientation, space, and consideration. Manual assembling process. Manual assembly with typically use the prototype with low volume work and opposed to assembly. Opposed to automated assembly with the odd form of the components of the both surface mounted technology through the whole technique for the components will be assembled manually within low volume of the work with the assembler list. Assemblers may be used within which each person with the resemble attaching specific component of the assembly problem is interrupted several times. The functional test of the section of the PCB as it is assembled. Manual assembly may involve both the manual and placement soldering of the next manual placement. Automated soldering described below. Manual assembly can be tedious with the consistently component placement with the orientation can be manual assemblers. For example, orientated polarized component of the capacitor and diodes in the same direction. Orientation integrated circuit so that the pin one on all integrated circuits is located in the same direction, significantly reduce the assembly defect for the increased yield. Automated assembly process, pick and place. Automated insertion process for the pick and play that exists for the bolt through the whole device for the surface mounted devices, include the both radial and axial lead the device for the automated machine with the ground program that extract the parts of the reels and bins, replacement of the component of the PCB, correct location orientation through a whole device can be typically populated with the rates of 20,000 components per hour to 40,000 components per hour, and program information automated placement with the machinery that can be supplied with the Gerber files AST and your ASB generated layout with the other CAM program. Computer-aided manufacturing programs. Through all devices, usually packaged with a whole roll of strips of the components wherever the taped together the leads with the root of the whole the components usually placed only with the top side of the board with the leads with the lower side of the components themselves are not exposed to molten solder. Solder process described below the typical automated process with the root of the whole device insertion dual inline package first, then the axial lead device radial lead device for the finally odd form of the devices after the component has been inserted the board most often were soldered but can reflow the solder and also described below. So for the mounted devices are commonly packaged in tools matrix tray with the tape of the reel with the bulk with the surface mounted devices may be mounted on one both sides of the printed circuit board. When attached to the top side of the soldered paste screen is printed with a PCB board soldered pads. The parts are placed on the board and picked in place with the equipment with the component with the lead termination and set into the part pays of the temporary holding the parts in place with the board is then run through with the reflow oven in which melts them and then cools the side thereby attaching the part to the board. Surface mounted devices are typically mounted populated rates from 10,000 to 100 components per hour. When surface mounted device are played with the bolt side of the PCB with the board contained with the bolt surface through the whole device is sequential with the reflow of the wave of the soldering profit that was employed with the finished top side surface mounted device with attached with the board using the solder pave with the reflow with the process for the described below. The next few the thorough holes of the devices are inserted from the top and held with the placement with the clenching with the bending with the leads with the bottom with the by gluing with the part of the thumbs of the top. In some cases with the friction between with the lead with the hole with the board is flipped over the adhesive of the dots are applied with the bottom of the board with the automated with the dispense of the bottom mounted surface devices, SMDs, are positioned manually with a pick and play with the machine with the onto the glue down with the adhesive hole for the bottom side of the surface mounted device and play for the solder joint has been completed. The assembly run through an oven cure with the adhesive of the board with the hole through a hole of the components of the top of the surface mounted device on the top of the bottom of the run through wave soldering station, which solders through leads and bottom mounted surface mounted devices of the board. Previously soldered top mounted surface mounted devices remain soldered on the top. While the PCB has only surface mounted devices has them on both sides of the two separate flowing with the soldering profit. Sometimes the two mounted surface mounted devices are attached to the board. First with a high temperature soldered plate, then board is then run through with a high temperature reflow over the top side of the component secure, and then the plate with the board is flipped over. The bottom of the surface mounted devices are attached to the lower temperature plate with the reflow of the process described below. Soldering process is both attached with the components physical to the PCB that provide electrical conductivity between the components led within the PCB trace with the solid process with a successful intermetallic compound alloy must be formed between the solder and the base material of the leads and trace to protect the solder joints of the areas of the oxidation contact area of the PCB receives surface finished by dipped into the solder bath with hot air solder leveled or plated by the same over the plating profit with electrical list nickel or palladium combs P32-1 just prior to the during the soldering surface of the bead joint are clean with the deoxidized with the flux of that so that the solder can flow over the wet surfaces. Two general types of soldering method of mass soldering, which include the wave and the oven oven and reflow, vapor phase reflow, and conductive reflow, and directed energy, which includes hot gas, hot bar, laser, iron, or pinpoint torch. Only manual wave soldering or oven reflow soldering will be discussed here and only briefly. Manual soldering is used with a very wide variety of the application from complete PCB assembly to simple rework of the repair work, the touch-up of the several times of the manual soldering tools available, including not limited to hot air pencil for the soldering iron, with the inductive coil with the other, with the slower soldering speed. With the biggest drawback for the manual soldering over the increased risk of the electrostatic discharge during the handling with the thermal gradient caused by the localized heating of the board part of the proposed parts placed on the board then will manually replace the solder with the required with no layers, no special layout with consideration as far as spacing orientation. Other than these boards, the basics described below will have the helpful with the assembler if the part placement of the floor of the room does work with a similar part of the line that orientate with a consistent manner that is described above. Wave soldering. During wave soldering with the board is held with the edge of the conveyor with the flux and preheated as shown in figure 5.1 and 5.2 with the conveyor moves of the board pass a standing wave of the molten solder, then often only to the bottom side of the board exposed with the side of the wave soldering can also be used with the both through hole devices and surface mounted devices. But reflow would be referred to the surface mounted device. Thorough hole components are placed with the top with the leads protruding with the bottom on the board, with which are pre-flux. After the conveyor moves over the PCB, the solder wave of the solder mixes up with the barrel and creates a fill on the top and the bottom. The surface mounted devices are glued with the board flux through the run through the wave. Very small components or large tantalum caps can be. Problematic with wave soldering with the small parts, but the problem due to the gluing process with the big cover. Some of the key for the glue dot that is larger than the component of the glue can ooze over the soldered parts with the large surface mounted devices cause problems because of the thermal stress that can lead to component cracking. And now we're going to look at figure 5.1, which shows the wave soldering view of the DIP with the dual inline package and the plated through hole. So for the surface mounted device reflow with the soldering with the surface mounted device, the DIP with the dual inline packaging, the thorough hole device, your solder wave, molten solder, and your solder joint soldered modern surface mounted device wave soldered. On the bottom one you see wave soldering review, the conveyor mechanism, surface mounted device reflow, glue dot, board traveling into wave or dual inline package, and the thorough hole devices and holding fixture. When surface mounted devices are wave side of the mount of the bottom side of the board, the designer needs to know, or specifically direct from the over the board, will through with the wave of the component should be played with on the board. Figure 5.3 show the smaller parts not shadowed by larger ports, which can cause the board poor soldering joints on smaller parts for the lower, so the solder brings does not occur across the lead. Alright, this shows the direction of the board travel to soldered thieves, the surface mounted device component with the orientation wave soldering. Solid bridging can occur to cover the fine lead pitch for the surface amount of the device. Each pin leaves solder wave tends to draw some of the side of the from the pin beside the molten solder attempt to reduce the surface tension for the orientation shown in Figure 5.3. This cover the problem last two of the rows of the pin. There are no pins that follow the draw of the excess of the solder away from them, which can resolve the last two pin with on the side bridge by excess solder on the method of the minimum of the bridge to play with the solder thief with the right trailing edge of the surface on the device. The integrated circuit is shown in Figure 5.3. Solid thieves are extra placed in the last pads of the pole with the excess of the solder away from the pads. Solder thieves can be also be made by simply making last pads little large, extending farther back with the typical pads on the device. And surface around the device with the parts on the top of the board, reflow of the solder prior to the wave starting with a fan out with the V with the knee with the located away from the lands, preventing solder mitigration away from the surface around the device. Lands down to the Viva. This is going to occur with the heat with the contact with the solder wave up to the V with the bear with the reflow with the solder with which to then draw with the solder down with the V with the capillary action that suggests the spacing of the less than or greater than or less than 20 mils in section, greater than or equal to 20 mils between the edge of the V and the edge of the plate, with the default space in the layouts between 50 to 75 mils depending on the setting. Some of the boards may be too large or too small with the B-wave soldered. Large boards sag as they have the heated and left. They specialized holding fixtures are used. Very small boards may need to be panelized without breakaways, tab routes, or V-scores so that they can be handled with automated equipment. While having many specialized board holders, panelization demonstrated in Chapter 11. Your reflow soldering. There's various types of the reflow soldering. With the discussion here is limited to the oven type of the reflow soldering. Reflow soldering is most often used in surface mounted devices, but thorough hole components can also be soldered this way. This can be called pin and paste or intrusive reflow soldering and schematic drawing reflow oven shown in Figure 5.4. 5.4 shows the reflowing soldering oven side view. You have the control conveyor belt. You have your control heaters. You have your surface mounted printed circuit board and insulated oven enclosure. Solder paste, which contains solder and flux of viscous paste, is applied with the bare board, where the stenciled components are placed in position, usually with a pick and place machines, so that leads sit in the solder paste. The assembly is placed on the conveyor, run through with the temperature for the control of the oven, heat of the boards and parts unevenly. As the assembly heats up, the flux activated the solder reflows from above the surface of the tension for the molten solder tin with itself the line in the parts. However, if the parts are not proper alignment, the thermal gradients do not melt the solder on all pad with the same type of the component may stand up at the end of the all tomb spinning once the assembly is reach proper temperature from the side of the reflow of the assembly exit for the oven and call for the solidify with the solder. Solderable components need to be selected with the both wave reflow soldering. It is also important not to play with thermal mass of the parts in the same area of the board as if the cause of the thermal gradients across the board. Poor solder joints formation in a cooler areas combs page 4312 of the board design combs 4325. Component placement orientation guide. PCB assembly consider the bare board of the attached component with the connection for the board can have a significant impact on how easily components can be placed on and attached to the board and how reliable the end of the picture and product is. The board topology, class, and level of the component technology is for the mounted device or through a hole and soldered method is attached to the parts reflow or wave soldering play a significant role in how the parts should be placed in space on the board. Component placement with the orientation depends on the type of the components of the TTH or surface mounted through a hole or surface mounted type. Assembly manual wave soldered yet free flow of electrical performance requirements electrical to discuss below for themselves do not make the board function better, but they do make it easier to assemble and inspect with the test and with the troubleshoot. General guidelines are: 1. Components should be placed so that they are neat, organized, uniform spacing alignment. 2. Components should be oriented so that the components are parallel to the board edge for the expectation not below the wave soldered. If the board is machine soldered with a through hole, the components should be mounted with a single side with the opposite side soldered wherever is possible. 4. When placing components both sides of the board when mixing through hole and surface mounted device technology, keep it in mind that multiple assembly phases may be required to play with all the components with increase the cost potential failure points of makes rework more difficult. 5. Do not put plastic lead chip carriers or PLCCs or large titanium capacitors on the bottom side of the board. Do not wave solder them as they can easily crack due to the thermal stress. 6. A 100 millimeter grid should be used if possible, but a 20 millimeter grid or even the 2 millimeter grid can be used required with the component leads with the non-standard grids. When metric grid is used with the grid of the 2.5 millimeters, 1.27 millimeters, 0.64 millimeters, 0.5 millimeters, and it should be used. A 1/10 of an inch grid should be used for the boards that undergo the bed of nail testing. 8 polarized capacitor diodes should be orientated and consistent with the route of the board, easier for the inspection and testing. 10. When making machine vision assisted assembly process for the use of the add fiducials group and local to a component placement. 10. If the design allows, the connector should be placed on the short side of the board when using automated solder process. 11. Will allow adequate spacing along the board edges during the component placement and the handling of the board of the accumulated mounting board. 12. Components weigh more than 5.0 grams per lead should make handling support with the board will explain with the vibration. 13. The thermal management during the solder process the circuit operation should be considered throughout the design process. 14. Electrical consideration using higher have priority over the mechanical consideration whether there is in conflict between the two unless it resolves the mechanical failure of the board. And 15. For mixed signal analog digital PCB components should be segregated with the minimum of the effect of the switching noise of the analog circuits. High power circuits could also segregate from low power low noise circuit. Component spacing through whole devices follow the table to provide minimum spacing guidelines for discrete integrated circuits through the whole devices, discrete through the whole devices, the discrete through the whole of the table 5 and 2, integrated circuit through the whole devices, integrated through the whole devices, table 5, 3, mixed discrete, integrated circuit through whole devices, mixed discrete, integrated circuit through the whole devices, table 5, 4, hole and jumper wires for holes and jumper wires, table 5, 5, component space and surface mounted devices, following tables provide minimum recommended space and guidelines, discrete, integrated surface mounted devices, discrete surface mounted devices, table 5, 6 devices, discrete surface mounted devices, integrated circuit surface mounted devices, table 5, 7, the mixed discrete, integrated surface mixed discrete integrated circuit mounted devices is greater any of the preceding space rules for the components involved with makes thorough whole device and surface mounted devices spacing requirements greater than any of the preceding space rules for the components involved, usually through the thorough hole T spacing. And then it goes over these charts, which shows the spacing. Alright, footprint pack same with the PCB the manufacturer for the main footprints and with the layout software, but you will need to make your own with the same point. Some point with the chapter 8 with the describe of the layout, fuels with the E with the design footprints with the file with the describe of the design with the consideration industry standard with the relay with the design footprints design with the surface mounted device with the thorough hole device with the significantly different than both required with the consideration PC with the manufacturer, some with the footprint lamp pan with the layout with the consider with the pads down with the silk screen with the opposite with the place outline, chapter 8 with the specified with the known port. It's not a component spacing spreadsheet with the layout with the route spacing spreadsheet with the footprint design with the place down the outline to some of the space therefore with the maximum board density possible which incur with the design requirement check errors per institute per printed circuit board standard with their several spacing the recommendations depending on the board's classification package type. The layout footprints generally fall within the integrated printed circuit board design standard for level A boards, but when not necessary for the design, particularly for the productivity level, the need to produce a level C board, you will need to modify to make new footprints and then follow the specified guidelines, or if you want a footprint to specify to meet level A requirements to increase the yield and reliability, then you may also design special footprints with modify existing ones. The following discover some of the design issues provided reference for the industry standards. Land pattern surface mounted devices. When you're doing a board layout with the pattern part, there's not a layout with a footprint in the library. There's several things you can do to construct one if the layout footprint is similar to the one you need, but it is wrong with the number of pins. You can save the copy existing the part with a new name and use it as a pattern to add pins. Reset the place for the outline silk with the screen is necessary. If the layout has no footprint, you can use the pattern for the next step of the take with the manufacturer data sheet with the SC with the suggested layout pattern. If it do not provide the necessary information you want to be able to find design parameters from the integrated institute printed circuit board land pattern viewer. If all else fails, you will need to design one from scratch using the package information component data sheet with one of the GEDEC package standards. Component data sheet and the GEDEC package standards should be provided information about the package dimension but not for the PCB land pattern. And typically with the Institute printed circuit board standards provide guidance for the land pattern dimension relative to the lead dimension, but it does it in so a way requires additional calculation to control the pad stack of the footprints in the layout. When you design footprints in the layout, you need to know the size of the pad stack or the distance between the center of the pads. The Institute printed circuit board standard typically provides spacing information in relation to the edge of the pad. So for the conveyance of the way of the translating the GEDEC package dimension directly into the layout, footprint directly maintains compliance with the Institute printed circuit board standards as needed. When you look up a parts data sheet with a dimension usually with regard to the package example with the 8-pin small online integrated circuit is shown figure 5.5. They may also be the GEDEC specification figure 5.6 illustrated with the GEDEC standard MS012 for an SOIC package for 5.6 reprinted with a permission GEDEC, and it showed the data sheet packaging limitation typical invention, and then it showed the with plating base metal, common dimension, symbolism, minimum, nominal, and maximum note, your GED's packaging dimension, typical convention. For the manufacturing instruction and/or standard that we need to determine the pad stack, the width, the height, the spacing between the pads in both of the X and Y directions shown in figure 5.7 in order to create a new footprint in the layout. So place outline width of the HP with the SE with the SE with the footprint dimensions typical convention. We begin with looking at the design pad stack file with the footprint design with the established pad stack. Surface mounted device with the pad stack design with the good pad stack. Remember the best possibility with the higher joint butt component with determination. Leave it within the PCB. Pad stack must allow for the component with dimensional variation. PCB the fabrication tolerance for the placement tolerance soldered filled with the specification thorough hole device for the relatively large, therefore more forgiving of those tolerances. Surface mounted devices are typically more smaller, but therefore most sensitive to the manufacturer placement variation. IPC 7351 is the same with the surface mount with the land pattern of the bowl of the pad stack of the footprint design. Shown figure 5.8, the solder pack with the pad stack needs to be larger for the component lead to allow for the proper soldering joint with the required pad oversight of the defined IPC 7351, page 8 with the 14, where the term JT determines the distance for the end pad of the toe lead, with the JH defined with the distance for the end pad to the heel of the pad, and JS defines the distance, the sides of the pad, the sides of the lead. Through JT, each of the head to the toe, the heel, and the sides, depending on the type of the component with the desired density level, the A through C with the nominal value with the provided table of 5.8, 5.9, and 5.10. Design a pad stack layout. We need to know the following width over the pad stack with the height of the pad stack, be able to fill with the required values of the pad stack spreadsheet. 7 figure 8, so for the surface mounted device package, side view and toe view, the toe solder filter, heel solder fillet, joint toe, heel, joint solder side width of the solder fillets. Alright, 5.8 is the nominal total solder fit value. You have the glue wing, go wing, J lead, J lead, chip components, 0603 larger, smaller than 0603, small outline, titanium capacitor, the leadless chip carrier, MELF, and butt joints. Then the nominal header heel solder fillet view in the package type of the go wing, J lead, small outline, chip components, all titanium capacitors, MELF, leadless chip carrier, and butt joints. And then you 510 show the nominal side solder fillet values, packaging, go wing, J-Lab, go wing, SOG, chip components smaller than 603 and larger, MELF, small outline, titanium capacitors, leadless chip carrier, and butt joints. 5.9 show the pad stack spreadsheet for the design, show the pad stack layer name, pad shape, with the pad width, of the pad height. Give the parameter of the component with the data sheet with the JEDE standard with the equations 1 and 2 with the committee with the determined maximum side with the width of the width and the height of the is E minus E with parameter with pad is E, the maximum is equal to E minimum minus E maximum times minus 211 times Anyways, when the mix width of the pads E minimum and maximum of the distance between the end of the lead with the GED dimensions, the E tolerance is the tolerance for the E per GEDEC dimension that are calculated from the E maximum. The end of the lead's pads are the minimum, and L is the length of the lead. What will be soldered over the pad of the GEDC dimension, figure 5.6. JT and JH are soldered fill allowances described in table 5.8 and 5.9, derived from IPC Institute printed circuit board 7351. F is the PCB fabrication tolerance. P is the placement tolerance of the pick and place machine. It depends on the machine of 0.15 mil or 6 mil is typical. The HP max is the maximum pad height, and B minimum is the minimum lead, where JS of the desired fit allowance is described in 510. BT is the tolerance of B per GEDC dimension calculated B max minus B1 minimum, figure 5.6. F and P are described in equation 1. These equations were derived from various tables of the IPC 7351 actual standard with included rounding factor but does not include with the equations 1 and 2. Table 5, 8, 5, 9, 5, 10 were also derived with the various tables of the IPC 7351 sources standard inch of additional data greater and lesser the density levels, which only with the nominal density level included. Please see with the source of the full dimensional consideration download the Institute Circuit Board land pattern view with the IPC website with a dimension demo version available for free. Once the pad is designed, you have the calculated width and the height of the procedures given in Chapter 8 of the create the pad and layout with the layout manager. The surface mount of the device floating program of design. Once the pad is activated with the need for the correctly located with the complete with the footprint design example, the IPC with the 7351 defines the land with the pattern parameters shown in figure 510 for 8 pins SOIC with the component outline defines the outermost boundary of the integrated circuit, including both edge and package for the end of the lead with the next courtyard defined with the round and the parts with include with the body and the basic land pattern with the courtyard is adjusted outward from the part over the lines to protrude with the end into the consume with the printed circuit board real estate with the amount with a protrusion called the courtyard access. Determine the minimum separation between the component with the during the placement with the greater of the courtyard access with the lower less densely with the printed circuit board population. Density level categorized in level A through C with the listed in the table 511 the various surface mounted devices in IPC 7351 table 34 through 314. Show the pad, your courtyard outline, your excess, and your protruded courtyard. Layout, you have the concept of the similar with but not exactly the same of the IPC 7351 land parameter with the surface mounted device with the footprint figure 5 of 11 and A show with the 8 pin SOIC with the outlines layout overlaid onto the IPC with the land pattern in figure 11 and B that show the actual layout footprint with the seen with the library manager. Note that the layout place outline does not include the access for the ends of the body, but the access be beyond the leads not the same as the IPC access. For most layout footprints include the software of the courtyard except for the 15 mil past the last end, that end of the between the density level of A and B with presumably, and there are artifact with the following earlier IPC stream with the IPC SM7880 with which general with the 30 mm space with the rule for the surface mounted device to make a layout design rule checked with the utility catch space from the violation. Many of the footprints are made within 15 mm with the courtyard 15 mm with each of the component result with the 30 mm of the total spacing, but the design rule check will not ensure the end-to-end space with the requirements of the layout footprint do not end with the excess pass of the body boundary. See for the component placement of the discussion below. In additional, some of the native layout footprints may not meet density level A specification, but in level B with the acceptable compact with the tight with as possible relative to the place outline and still have room to spare. If you want to pack with the components tighter still level C with the density that you will have with the bottom 5 of the footprint place outline obstacle to prevent the beginning of the design rule check errors. Since there are no component spacing in the spreadsheet layout, there is the route with the spacing spreadsheet with the you'll have the rear rely on the footprint design place with the outline obstacle with the design rule check with the meet with the design stand with the footprint place outline with the design to meet the standard constraint with that it is up to the PCB to design consistent with the component spacing. While placing the M parts on the board, you can use the table 5 and 6 as guides. And then we'll go back. This shows table 511 courtyard access with the protrusion, the density level of the various surface level devices. You have the density level A in mils and millimeters, and density level of 3 with the gull wing J, the small outline chip component 603 or bit larger tandem MELFs, lead chip carrier chip components and butt joints. And then we have what we see with the comparison layout footprint of the Institute printed circuit board land pattern layout outline integrated circuit layout SOIC footprint. Not accounted for layout place in excess of the SOIC, and then the place outline in your component outline silk screen courtyard access. Alright, land pattern through hole devices. Standard foot design with the through hole devices are pattern, perhaps not widely known, but is the surface mounted device that partially become with the greater value with the package style through the hole device, partially become with the typical large side with the banks, some of the less sensitive with any of the design manufacturer issues, weighted with surface mounted devices. The result of the land pattern shown by the guide through the whole device is hard to come by with any device may not exist for the others. For the section we look at how the design footprint pads stack with the through whole device. Through footprint and design through whole devices. Through whole devices are generally in one of two categories. Axle lead with the radio lead. For example, the radio lead is a capacitor shown in figure 512 with the footprint design type. Show the radio lead with the whole device with the axle leader with the layout axle footprint. Place outline component outline silk screen. On the device, determined strictly with the construction of the device, clear with the plastic have been located lead extend with the body of the radio lead devices, include the pin and gear ready to be raised. Many of the discrete transistor devices shown in the TO220 and TO92 package of the only variable of the pad stack design, regardless of the lead timers, the pad stack design is described below. Footprint of the devices component with the axle leads have variable component radio lead device for the Iron Institute printed circuit boards SEM 7070 section 1118 page 67. Others from the literature provide with the guidance of the footprint design figure 513 illustrate the design parameter of the axle level component. In this case, the K urban resistor location of the pad stack depends on the length of the body, location of the lead bends, and lead form of the minimum required distance between the pad stack with the calculated equation 3. LP is the pad spacing the center of the LB is the length of the body, DL with the diameter of the leads, LE the length of the lead, extension of the body, and the bend, and the N is the integer allowance of the bend, radius of the base of the lead to determine diameter per table of 512 of the pad stack calculations described in the next section. Once the minimum pad stack space for the calculated pad stack should be placed in the closest grid location. Standard grid spacing is described under component placement orientation guide and not most in case of 100 mil grade. So, Fab 13 shows the generic footprint of the dynamic design parameters of the axle lead components. B, A show the radial resistor, and then B show the layout radial format footprint. So you have the placement component of the outline spoke stream, and then you have the radial footprint with the number 2 lead diameters. Achieving the total length of the both end leads should not exceed 1 inch unless the component is mechanically supported. Pad stack the design throw hole device with the big vulnerability printed circuit board fabrication plate through the hole with the big cover with the registration error. The aspect ratio plating and such are likely the failure of the points are breakout angular with the ring control with the dude with the misalignment the open to the dude with the threat stress the cycling during soldering process. Similarly in rework, but if we follow the standard fabrication design guidelines, we'll have little to trouble. In designing the plated throw holes from throw hole components, we need to consider the lead diameter of the drill relation with the PCB thickness of the drill, the hole relationship, aspect ratio of the width of the copper ring around the hole with the angular ring, the clearance of the plane layer with the plate through holes, with the capability of the board manufacture both combs and iron to printed circuit board standards. Earth salt here to define the process design of the printed plated throw holes is layout. Hold the lead ratio of the side of the plated throw hole should be large enough so that the lead can easily slip into the hole, but should not be large to prevent capillary action during soldering operation. The two methods of determining required hole size with the relative of the diameter of the lead with what will be soldered into the first method derived with the combination IPC 2221A, section 913, page 74, comb, section 4221, page 42.3. The method takes into account plate thickness either assumed or known. Always design and define the tolerance factor for the methods produced with the clearance between the lead and the plated throw hole that varies with the diameter of the lead. The drill size is calculated in equation 4. TH of the drill hole layout is equal to the diameter of the lead per component data per sheet or measurement plus 2 times the thickness of the plate inside of the hole times is known as TP. The thickness of the plating is also known as 1 mil. And times K is usually the tolerant factor for which is 1.05 is less than K, but K is less than 3. Example of the diameter component lead. The diameter lead is 32 mil with the drill hole side, with the drill hole side with the 32 plus 2 with the times 1 times 1.5 with the equal to 51 mil with the exemption of the variable K. The user tolerance is relatively easy to use. However, the lead diameters become larger and clearance between the lead and the hole becomes wider at some point, but the clearance may be too large for the proper capillary action to take place. The point at which the occurs is not well documented within literature. Second method is used to lock up a table in which the drill hole size depending on the lead diameter of the desirable productibility level A through C, with it shown with the table 5 to 13 from IPC 2222 table 9.3 with the page 20. Some of the examples use the massive within the same with the 32 mil lead with the diameter data page sheet specifying 10% tolerance for the lead diameter and the maximum lead diameter of 35.2 mils and a minimum of 20.8.8. If we were productively level A, the hole diameter would be between 36.2 and 36.2 times 35.2 plus 10 and 56.8 times 28.8 plus 28. Then table 5.3 shows the hole lead size relationship with the productivity level, the hole size, the level of A, B, and C in mils and millimeters, minimum and maximum lead diameter positive, minimum and maximum and minimum lead diameter positive. If you search the internet, you can find the algorithm calculating the proper hole with the lead ratio for the method. If you choose up, the two methods we are derived from the Institute Printed Circuit Board standards, all of their sources, but they are not hard to find. Vast requirements. Plated through hole length dimension for the annular ring width. One side of the drill hole will determine the next step will determine the diameter of the pad. That scope called for the length of the difference between the pad diameter and the drill hole diameter of the called for the angular ring. This capillary area with the solder joint is made with the component of the lid of the larger of the pad diameter, the larger of the solder joint will be to the point where the large pad does not decrease makeup with the better solder joint of the only increase the amount of the heat but the required is make the solder joint too small of the pad can make it the weaker side of the joint and of the pad can easily be damaged with the heat with the mechanical strength of the lid off from the pull with the pad diameter recommended by the Institute Printed Circuit Boards 2221A page 73 with the calculated equation 5. The diameter of the pad is equal to the finished hole size plus the 2 times the B, the minimum annular ring requirements plus from, and plus C, the standard fabrication allowance in Table 515, IPC 2221A, Table 9.1. Figure 514 shows the plated through design parameters, DP with the pad diameter, DL with the diameter length, A as your finished hole size, B, and DH would be your diameter hole. As example, if we use the 32 mil level, the example above, using the hole size of the 50 mils, we're calculating the size of the external pad with the top of the bottom of the layout. We want level A productivity, level of the pad side would be 50 minus 2 times 1 plus 2 times 2 times 6. So plus 16 would be 68 mils. Clearance between the plates with the layer with the plated through holes. Plated through holes even typically have the lands of all the layers, even if they are not connection with the one the layer. They also call it the non-functional lands. IPC 2022 with the shape of the non-functional leaf should be used the internal layer with when possible. The non-functional land is not required in every layer of the board is over 10 layer thick. And they are not required on the plane layers for the V of the plate through the hole through a plane linear layer with the minimum amount of the space required between the plane and plated hole is non-functional land to allow the fabrication along with the minimum of the wicking and plating solution of the laminate through the hole with the resulting internal shores of the internal plane layer and to meet the voltage withstand insulation requirements. The IPC 2221A section 631 page 42 state of the trace with the traceless space requirements see off the table 6A with the chapter 6 with the next of the text apply with the clearance between the plane edge of the plated through a hole and its land with the furthermore per IPC 2222 page 17 figure 9.1 with the minimum clearance between the plane edge of the internal non-functional lands plated holes with the minimum of the 10 millimeter with the clearance diameter of to be 20 millimeters larger than the drill hole's diameter. The pad stack and layout with the do not contain with the non-functional land with the plane layer with the clearance of the diameter should be 20 mils larger for the drill hole diameter. Most of all of the pad stack with the footprints include layout libraries may be recommended for the clearance of the pad stack if it's not designed this way, but does not cause a problem during fabrication or operation of the board. If you find the pad stack does not meet the recommendation, check your board manufacturer specification to determine the change if required. If a land or pad is designed in equation 5 above with the minimum clearance between the holes, the plane is used with the clearance diameter of the typically with the treble panels larger than the land, but the lands are larger than the clearance diameter. However, they will overlap the lands of the plane layer with the shown figure 5 even the clearance and distance dimension D that meets the Institute Conventional Printed Circuit Board standard. They should be avoided. There will be capacitive coupling between them, and this shows figure 515 plated through hole V for the oversized lands with the overlapping plane, ground and power plane V for the land. Pad and plane which can alter with the characteristic impediment with the tray with the cod cover with the crosstalk with the problems with the high freak with the characteristic impediment with the described with the greater with the detail in chapter 6. Another thing to pay attention with the clearing of the diameter should no longer be necessary with the larger slot with the ground with the return of the plane with the result of the trouble of the plane with the close together the edges in the board and sock connector in which cover the problem with the high speed with the digital with the high frequency analog requirement signal lines between the pin with the force return with the signal line the ground planes go around open to the slot with the ground plane increase the loop with inductive and C with the circuit will we'll look at the loop inductancy and group planes in Chapter 6. Solder mass and solder paste dimension. Solder mass will be the typical same type of the plat of the land, diameter of the layout of the board. The manufacturer can sometimes require particular oversight of the opening of the 5 mils, not typically uncommon, but it does not automatically adjust the type of what you need to modify with the solder mask open before you post-process the printed circuit board design. You can do this with the footprint level of the printed circuit board itself. The solder paste with the dimension usually same side of the external lane with the top and the bottom layers. In this case, we move the layout footprints, but some of the footprints that do not have the solder paste defined. If you will need solder paste definition, make sure that you properly specify what the specific assembly needed. Alright, Chapter 6, printed circuit board design and signal integrity.